Firebase is a powerful platform for building amazing apps. You've got robust databases, authentication, hosting, and now AI integration tools like the Firebase AI SDKs, Genkit, and even vector embeddings in Cloud Firestore. But let's be real, how do you use them? When does each make sense? And seriously, they seem so similar. Do you need complex backend work, or can you keep it simple on the client with the tools you already love? How do you make sure these AI features are robust, secure, and production-ready, giving your users a smooth experience? Hey, I'm Peter, and today I'm going to demystify all of this, showing you exactly how it works and when to choose which Firebase AI tool. To show you how these features can be used in a real-world scenario, my team and I have been working on a meal planning app to collect and store our favorite recipes. Users can add their own recipes, browse them, and then get this beautifully designed screen that helps them with the cooking. This is great, but we found that it's often difficult to decide what to cook. So we came up with a couple of ideas to make it easier and more fun for users to discover new recipes and help them decide what to cook today. For example, a user might want to surprise guests at a dinner party with a meal in the style of a particular cuisine. We also wanted to build something that helps the user decide what to cook based on what's in their fridge. Just snap a picture of what's in your fridge and get a suggestion for a recipe. How amazing would that be? And of course, since users can store their favorite recipes in this app, for example, their grandma's apple crumble, we want to ensure the app provides recipe suggestions that consider their personal collection. To kick things off, we started by prototyping a prompt in AI Studio, and honestly, the results were pretty impressive. Check this out. We asked for a vegan Turkish recipe for 4, and it gave us a full ingredient list and detailed steps. AI Studio has a handy feature that gives you the working code in the language of your choice for generating the response from this prompt, including the code to generate the recipe as JSON structured output so that we can easily parse and render the result into the app's UI. To use this code in our app, we need to make sure the app is connected to Firebase and that it has the Firebase SDK installed. Since our meal planning app uses Firebase to store recipes in Cloud Firestore, we've already connected the app to a Firebase project. But if you'd like to learn how to set up your app to use Firebase, including creating a Firebase project and connecting your app to Firebase, here is a video that walks you through the steps. And since this is an iOS app, adding the Firebase SDK to your app is, of course, done using Swift Package Manager. With that out of the way, we can connect our UI to the code. Now we can run the app and try out the new feature. Let's see. I think I need a dessert for 4 people. This sounds great. But wait, doesn't the Gemini API require us to provide a Gemini API key? And isn't adding that API key into our app's codebase a security risk? It is indeed, as anyone can now download the app, open it in a hex editor, and exfiltrate your Gemini API key. A malicious actor can then use your API key to make calls with it, racking up charges on your account. So, you should never, ever put your Gemini API key directly into the codebase of any app that you want to make available publicly. The best way to protect your precious Gemini API key from being stolen is to never put it into your app in the first place. The good news is that Firebase has built a solution to help secure your app from these malicious actors. When you use the Firebase AI SDKs to access generative models like Gemini, you don't put a Gemini API key directly in your app. Instead, the key stays on the server and can only be accessed by a legitimate request from your app. This is achieved by using Firebase AppCheck, which helps you to protect your app's backend resources and make sure it only serves requests that come in from your legitimate app running on untempered devices. Now that we've got a basic AI feature built in our app, we are ready to implement the next, even cooler feature, suggesting a recipe based on a photo rather than only text. If you're anything like me, you've stared in your fridge, totally stuck for dinner ideas. I usually fall back on the same old recipes. But imagine if your app could actually suggest something new and exciting based on what's already in your fridge. Users could simply snap a photo, and we can combine that snapshot with the text prompt describing their desired dish, sending it to the AI. This combination of visual data and text is called multimodal input. In this code snippet, you can see that passing the user's photo to the model requires just a small change to our code. We add the photo as an additional parameter to the generateContent method, and that's it. Great, let's give this a try. Okay, so let me take a picture and see what it comes up with. So I'm taking a picture of this plate of fruit here. And yeah, this sounds delicious. But to be honest, I am struggling to picture what this dish actually should look like. Wouldn't it be amazing if we could ask the model to generate an image of the finished recipe? Using the Firebase AI SDK, I can make a call to Imagen, our image generation model, and prompt it to generate an inspirational picture of the dish based on the text of the recipe. Let's give this a try. And this is a lot more inspiring than just looking at the text of the recipe. It's true, a picture is worth 1,000 words. So, we've added a couple of really cool features to our app with just a few lines of code, and we were able to do all of this on the client, using the tools and programming language we know and love. However, you might have noticed that all of the recipes that Gemini suggested for us were based on its foundational training data. And while I appreciate that Gemini can surprise me with a wide variety of recipes, our users might actually prefer custom recipes that are based on the collection of personal recipes they've stored in the app. For example, our users might have a collection of recipes that have been passed down several generations in the family. Or in a future version of the app, we may decide to offer recipes created by famous chefs as an in-app purchase. How can you implement this? Well, first, the user takes a photo. Our app then uploads that photo to Gemini and prompts it to detect the ingredients. We should probably make sure to get this list of ingredients as structured output to make it easier to work with. Then, we'll check this list of ingredients and retrieve all of the user's personal recipes that can be prepared using those ingredients. And finally, we will prompt the model to generate a new dish that is inspired by these existing recipes. As you can see, we need quite a few model capabilities to implement these features. Multimodal input to understand what's in the photo of the user's fridge. Retrieval augmented generation to fetch matching recipes from the database. Multimodal output to generate a new recipe with corresponding image of the dish. Tool use to call an API to order any missing ingredients. Let's think about the implementation of this feature. Sure, we could run the entire process, detecting ingredients, retrieving recipes, generating a new recipe, and even ordering any missing ingredients directly in the app using these client SDKs. But let's be honest, in this scenario, This might not be the ideal solution, as you'd have to coordinate different services and transfer potentially a lot of data back and forth between your client app and those services. By moving this complex flow to the backend, we drastically reduce the amount of data being transferred. This translates to faster response times, a better user experience, and less strain on the user's device, especially on spotty networks. And this is where Genkit comes in. Genkit is Google's open source AI integration framework. It allows you to implement AI flows using TypeScript, and we've just announced support for Go and Python. Genkit flows are like regular functions, which means you can do anything that you would also be able to do in any other function, like calling other APIs, retrieving data from a database, performing computations, etc. But the cool thing is that Genkit flows are observable, and that means you can monitor them using the AI monitoring dashboard in the Firebase console, or any other tool that supports OpenTelemetry such as Google Cloud's Observability Suite. Genkit also provides easy-to-use abstractions for working with models and vector stores. And this enables us to tap into any of the recipes our users have stored in their app's database and use them to generate new recipes based on the ingredients the user has on hand. Another really cool feature of Genkit is its unified model interface. This allows you to use different models by just providing the name of the model you want to use instead. This makes it super easy to experiment with different models. Let's take a look at how you would implement the meal planning use case with Genkit. First, we create a Genkit flow. Then, we pass the user's input to the model, prompting it to detect which ingredients can be seen in the picture. By providing an output schema, we can tell Genkit to work with the model to return structured output, which will make it easier for us to further process the result. Now that we have the list of ingredients, we need to find matching recipes that also fit the user's needs. Things like dietary restrictions and preferred cuisines. That's no easy task when dealing with complex search queries. Retrieving relevant data from a database based on free-form inputs, such as natural language or a list of ingredients, is a common challenge in AI applications. That's where Genkit's retriever abstractions comes in. It streamlines this complex process, making it surprisingly efficient. You can think of the retriever as your intelligent search assistant. It takes the user's request, translates it into a vector embedding, and then uses nearest neighbor search to quickly locate the best matching recipes in your database. Vector embeddings are essentially a way to turn text into a series of numbers that a computer can understand. Here is the number representation for apples. And here is the number representation for oranges. Since these are vectors, we can use mathematical functions like cosine to measure how similar they are. This allows our system to understand that apples and oranges are both fruits, even though they're different. So it turns out you can compare apples and oranges. Our recipes are stored in Cloud Firestore, which supports vector embeddings. So when the user stores a new recipe, we also calculate vector embeddings for its ingredients and store them alongside it. Genkit's Firestore retriever can then use those embeddings to quickly find the recipes that best match a user's ingredients, like those detected in their fridge photo. The result is a number of Firestore documents that contain the best matching recipes. Using these recipes, we prompt the model to generate a brand new recipe for the specified number of people, taking inspiration from the recipes found in the database. This flow does a lot with a few lines of code, thanks to Genkit's powerful AI abstractions. Now, you might be wondering how we can include this Genkit flow in our mobile application. After all, our client app is written in Swift, and the Genkit flow is written in TypeScript. To bring those two worlds together, we will first expose the Genkit flow as a callable Cloud function. This will allow us to deploy it to Cloud Functions for Firebase or Cloud Run. We can then use the Firebase Client SDK to call this endpoint from our Swift app. So, we've implemented 2 exciting new features for our app and we are ready to ship them to production. But before we can do that, we need to make sure that our app is safe from unauthorized access. AppCheck is Firebase's solution for keeping your app's backend resources safe. This works both for Firebase resources as well as your own custom backend. We can use AppCheck to protect the backend services our app uses. First, we need to register our app with AppCheck in the Firebase console. Next, we will add the AppCheck library to our client app. Then, we configure the AppCheck provider we want to use. This needs to happen before you initialize the Firebase SDK. Once you start out rolling the app, you will see your app's requests showing up in the AppCheck section of the Firebase console. You can now enforce AppCheck for your app, and as soon as you do that, only legitimate requests from your app will be permitted and all other requests will be blocked. Now that we implemented these AI features in our app, we want to see how they are performing both in test and production. To enable telemetry for your Genkit flows and other actions, add the following lines to your source and then redeploy. The next time you call your deployed Genkit flows, telemetry data will be collected. To see a high-level overview of the Genkit flows deployed in your Firebase project, visit the Firebase console. At the top, you will see the vitals of your Genkit flows, such as the number of requests, the success rate, and the latency. At the bottom of the screen, you can see a list of all the deployed Genkit flows of your project. You can drill into individual flows to see more details, most importantly, how many tokens or images they consumed or produced. But there is more. You can see the input and output parameters, and when you click on an invocation, you can see the entire trace of your flow. With the Trace Inspector, you can examine every step of the flow invocation in detail. It reveals the input and output of each step, along with any associated attributes. This allows for a granular understanding of the flow's execution process. This is a really valuable tool to help you gain insight into the performance of your AI features in production, and it's a great help when optimizing or debugging your Genkit flows. You can also inspect any invocations that fail, like this one. This is a great help for understanding why some of your invocations might have failed. All of this is possible because Genkit flows and all of their underlying actions are observable. You don't have to add any additional instrumentation, it's all built in. And there you have it. We've implemented a bunch of exciting new features for our app, making use of the AI services available from Firebase. We use the Firebase AI SDK to call Gemini to generate recipes based on the user's input. We used both text input and multimodal input, allowing our users to generate recipes based on what's in their fridge. We then used multimodal output to generate recipes, including inspirational images showing what the meal should look like. We were able to implement all of this in our client application using the same tools and languages that we're used to as mobile developers. We then switched it up a gear and used Genkit to implement a feature that grounds the model in the user's data, which allows the app to provide results that are based on the user's personal recipes. And finally, we made our application ready for production and looked at how Firebase's AI monitoring features can help us operate the AI features of our app with confidence. So, now you might be wondering when you should use the Firebase AI SDKs versus Genkit. The answer is, it depends on your use case. If you're implementing features that don't require you to tap into a large dataset or data of any other backend services, the Firebase AI SDKs are a great way to add powerful AI features to your app. As you saw, it's easy to get started and you have access to a wide spectrum of generative AI features. On the other hand, if your use case requires you to tap into a large dataset, for example, a product database, or if you need to connect your model to other backend services, Genkit is the best choice. It allows you to implement AI flows that integrate all those various services and make them accessible to your client application via callable API endpoints. Genkit is also the go-to way if you'd like to integrate non-Google models like those from Anthropic or OpenAI. Finally, keep in mind that this isn't an either-or decision. As you saw in our example, you can have the best of both worlds by using the Firebase AI SDKs and Genkit in the same app. Pick the best tool for the job. Thanks for watching, and I will see you in the next one.